Welcome to Maths Companion. In the last video, we have learned one identity. To multiply a sum of positive numbers by a sum of positive numbers, multiply each number in the second sum by each number in the first sum and add. Or we can say a plus b into c plus d equal to ac plus ad plus bc plus bd. There were two homeworks. Let us check the answer now. First one 32 into 43, second one 10.3 into 20.2. 32 into 43. 32 can be written as 30 plus 2 and 43 can be written as 40 plus 3. So 32 into 43 can be written as 30 plus 2 into 40 plus 3. Using the identity, we can write it as 30 into 40 plus 30 into 3 plus 2 into 40 plus 2 into 3. 3 into 4 is 12. Therefore, 30 into 40 is 1200. 30 into 3 is 90. 2 into 40 is 80. 2 into 3 is 6. So, this can be written as 1200 plus 90 plus 80 plus 6. 1200 plus 90 is 1290. Plus 80 is 1370 plus 6 is 1376. Therefore, 32 into 43 is 1376. Second problem, 10.3 into 20.2. 10.3 can be written as 10 plus 0.3. 20.2 can be written as 20 plus 0.2. Therefore, 10.3 into 20.2 equal to 10 plus 0.3 into 20 plus 0.2. Using the identity, we can write it as 10 into 20 plus 10 into 0.2 plus 0.3 into 20 plus 0.3 into 0.2. 10 into 20 is 200. How can we multiply 10 and 0.2? First of all, multiply 10 and 2 without decimal point. 10 into 2 is 20. Now in this product, there is only one digit after the decimal point. Therefore, in the product, there should be one digit after the decimal point. After putting the decimal point, we can write it as 2.0 and that is equal to 2. That means 10 into 0.2 is 2. In the same way, 3 into 20 is 60. And there should be one digit after the decimal point. So we can write it as 6.0 and that is equal to 6. Now 0.3 into 0.2. 3 into 2 is 6. There should be two digits after the decimal point. And 6 means there is only one digit. Therefore, put a 0 before 6 and we can make it as 0.06. 2 plus 6 is 8. 8 plus 200 is 208. Plus 0.06 is 208.06. Now let us do some more problems using this identity. Consider a calendar for any month. Now mark 4 numbers in a square like this. Now multiply the diagonal product. 1 into 9, that is 9. 8 into 2, that is 16. What is the difference between these two numbers? We know 16 minus 9 is 7. Let us take another square of 4 numbers. Find the diagonal product. 5 into 13 is 65. 12 into 6 is 72. What is the difference between these two numbers? Again 7. Now let us take another square of 4 numbers. 23 into 31, that is 713. 30 into 24, that is 720. What is the difference between these two numbers? Again 7. Is it always 7? You can check by taking more squares of 4 numbers and we can see that it is always 7. Now let us prove it using algebra. In a calendar for any month, mark 4 numbers in a square. Multiply the diagonal pairs. Find their difference. Is it always same? Why? Let us take the calendar once again. We can mark a square of any 4 numbers. Let us use algebra. Let me take the first number as x. Then what is the second number? When the first number is 1, second number is 2. When the first number is 5, second number is 6. When the first number is 23, second number is 24. Because the second number is the next day. 1 is Wednesday, 2 is Tuesday, 5 is Sunday, 6 is Monday, 23 is Tuesday, and 24 is Friday. So if the first number is x, what is the second number? It is the next day. So it is 1 more than x, or it is x plus 1. Now let us look at the third number. When the first number is 1, third number is 8. When the first number is 5, third number is 12. When the first number is 23, third number is 30. How do we get the third number from the first number? 1 plus 7 is 8, 5 plus 7 is 12, 23 plus 7 is 30. It is the same day in the next week. Therefore, we have to add 7 to it. That means, if x is the first number, to get the same day in the next week, we have to add 7 to it. Or, the third number is x plus 7. Now observe the fourth number. When the first number is 1, fourth number is 9. When the first number is 5, fourth number is 13. When the first number is 23, fourth number is 31. How do we get the fourth number from the first number? 1 plus 8 is 9. 5 plus 8 is 13. 23 plus 8 is 31. Therefore, if x is the first number, the fourth number is x plus 8. When we add 7 to it, we get the same day in the next week. Again, if you add 1 to it, we get the next day in the next week. So let us take the four numbers as x, x plus 1, x plus 7, and x plus 8. Now let us find the diagonal product x into x plus 8. What is x into x plus 8? X into x plus x into 8. X into x is x square. X into 8 is 8x. Therefore, x into x plus 8 is x square plus 8x. Now let us take the next diagonal product, x plus 1 into x plus 7. You can multiply using the identity which we have learned. X into x, that is x square. X into 7, that is 7x. 1 into x, that is x. 1 into 7, that is 7. So we can write it as x square plus 7x plus x plus 7. Now 7x plus x means 7x plus 1x. So this is 8x. So we can simplify it as x square plus 8x plus 7. This contains x square. There is no other term containing x square. So we can write it as it is. 7x plus x is 8x. And there is only one number without variable, that is 7. So x plus 1 into x plus 7 is x square plus 8x plus 7. Now look at these two expressions, x square plus 8x. Here x square plus 8x plus 7. Clearly this is 7 more than this. That is, this is 7 more than x into x plus 8. Therefore, the difference between the diagonal product is always 7. Now consider a multiplication table like this. As in the calendar, mark 4 numbers in a square like this. Instead of diagonal products, let us find the diagonal sums. 1 plus 4 is 5, 2 plus 2 is 4. The difference is 1. 12 plus 20 is 32, 16 plus 15 is 31. The difference is 1. 6 plus 14 is 20, 7 plus 12 is 19, the difference is 1. 28 plus 40 is 68, 32 plus 37 is 67, the difference is 1. Is the difference of the diagonal sums always 1? Let us check. Make a multiplication table like this. Mark 4 numbers in a square. Find the diagonal sums. Find the difference. Is it always same? Why? Let us consider the multiplication table. Here, this denotes the row numbers and this denotes the column numbers. In the first column, you can see multiples of 1. Second column, you can see multiples of 2. Third column, you can see multiples of 3 and so on. And this is the first row, second row, third row and so on. Now let us take any number in this multiplication table. For example, let me take this 10. It is in the fifth row and second column and the number is 5 into 2 or 10. Now let me take this 28. It is in the seventh row and fourth column. 7 into 4 is 28. Now if you take 48, it is in the eighth row and sixth column and 8 into 6 is 48. That means any number in this multiplication table is the product of its row number and column number. Now when we take 4 numbers in a square, they are in 2 consecutive rows and in 2 consecutive columns. We can mark any 4 numbers in a square. Suppose 2 numbers are in the xth row, then where will be the other 2 numbers? Here the 2 numbers are in the second row, then the next 2 numbers are in the third row. Here the 2 numbers are in the fourth row and the next 2 numbers are in the fifth row. Here 2 numbers are in the seventh row and next 2 numbers are in the eighth row. That means if 2 numbers are in the xth row, then the next 2 numbers are in the next row and the next row is x plus 1th row. In the same way, if 2 numbers are in the second column, the other 2 numbers are in the third column. If 2 numbers are in the fifth column, then the other 2 numbers are in the sixth column. If 2 numbers are in the seventh column, other 2 numbers are in the eighth column. So if 2 numbers are in the yth column, then the other 2 numbers are in the next column or y plus 1th column. And we have seen that any number in this multiplication table is the product of its row number and column number. For this number, the row number is x and column number is y. Therefore, this number is x into y or xy. In the same way, this number is x into y plus 1 and this number is x plus 1 into y and this number is x plus 1 into y plus 1. That means the 4 numbers are xy, x into y plus 1, x plus 1 into y, x plus 1 into y plus 1. Let the numbers are in the xth and x plus 1th rows and yth and y plus 1th columns. Then the numbers are xy, x into y plus 1, x plus 1 into y, x plus 1 into y plus 1. Now let us find the diagonal sums, that is xy plus x plus 1 into y plus 1. We can write xy as it is, but we have to multiply this. X plus 1 into y plus 1. X into y is xy, x into 1 is x, 1 into y is y, 1 into 1 is 1. So this can be written as xy plus xy plus x plus y plus 1. Xy plus xy is 2 times xy. So this can be written as 2xy plus x plus y plus 1. Now let us find the other diagonal sum. X into y plus 1 plus x plus 1 into y. X into y is xy, x into 1 is x. So this is xy plus x. Y into x is yx or xy. Y into 1 is y. So this is xy plus y. Xy plus xy is 2 times xy. So this can be written as 2xy plus x plus y. Now look at these two expressions. 2xy plus x plus y plus 1. 2xy plus x plus y. Clearly this is 1 more than this. Therefore, the difference of the diagonal sums is always 1. While doing the previous problem, we have seen that x plus 1 into y plus 1 equal to xy plus x plus y plus 1. This can be used to find the product of certain numbers easily. For example, suppose we have to find 71 into 81. 71 can be written as 70 plus 1 and 81 can be written as 80 plus 1. So 71 into 81 can be written as 70 plus 1 into 80 plus 1. And this can be written as 70 into 80 plus 70 plus 80 plus 1. 70 into 80 is 5600 plus 70 is 5670 plus 80 is 5750 plus 1 is 5751. Another example, 51 into 61. 51 can be written as 50 plus 1 and 61 can be written as 60 plus 1. So this can be written as 50 plus 1 into 60 plus 1, and this is equal to 50 into 60 plus 50 plus 60 plus 1. 50 into 60 is 3000 plus 50 is 3050 plus 60 is 3110 plus 1 is 3111. Suppose we know the product of two numbers, then this identity can be used to find the product of two numbers which are one more than the given two numbers. For example, suppose 17 into 25 equal to 425. We have to find 18 into 26. 18 is 1 more than 17, 26 is 1 more than 25. Therefore, we can write 18 into 26 as 17 plus 1 into 25 plus 1. And this is equal to 17 into 25 plus 17 plus 25 plus 1. Given that 17 into 25 is 425, 425 plus 25 is 450 plus 17 is 467 plus 1 is 468. That means 18 into 26 equal to 468. Now let us derive some more identities from this. Suppose we replace 1 by 2 and write x plus 2 into y plus 2. X into y is xy, x into 2 is 2x, 2 into y is 2y, 2 into 2 is 4. So this can be written as xy plus 2x plus 2y plus 4. 2x plus 2y can be written as 2 into x plus y. So this can be simplified as xy plus 2 into x plus y plus 4. This can also be used to find the product of certain numbers. For example, 32 into 42. 32 can be written as 30 plus 2 and 42 can be written as 40 plus 2. So this is equal to 30 plus 2 into 40 plus 2. And that is equal to 30 into 40 plus 2 into 30 plus 40 plus 4. 30 into 40 is 1200. 30 plus 40 is 70. 2 times 70 is 140. 1200 plus 140 is 1340 plus 4 is 1344. Now we can replace 2 by 3. We will get a different identity. X plus 3 into y plus 3. X into y is xy, x into 3 is 3x, 3 into y is 3y, 3 into 3 is 9. So this can be written as xy plus 3x plus 3y plus 9. 3x plus 3y can be written as 3 into x plus y. So this can be simplified as xy plus 3 into x plus y plus 9. Similarly, we can change 3 by 4 and we can write x plus 4 into y plus 4 is xy plus 4 into x plus y plus 16. Now let us generalize. Instead of numbers, let me take a. A can be any number. Then x plus a into y plus a equal to xy plus a into x plus y plus a square. Today we have done some problems using the identity a plus b into c plus d equal to ac plus ad plus bc plus bd. Also we have seen some more identities from that. X plus 1 into y plus 1 is xy plus x plus y plus 1. X plus 2 into y plus 2 is xy plus 2 into x plus y plus 4. X plus 3 into y plus 3 is xy plus 3 into x plus y plus 9. X plus 4 into y plus 4 is xy plus 4 into x plus y plus 16. And lastly, we have generalized x plus a into y plus a equal to xy plus a into x plus y plus a square. Now there are some homeworks. First one, 21 into 31. Second, 52 into 72. Third, 24 into 54. Using the identities which you have learned, you can easily find out these products. In the next video, we shall do the remaining part. Till then, bye.